All right, let's jump right in. Today, we're talking about a new piece of technology that is, and I'm not exaggerating here, truly revolutionary. It's a completely new way of thinking about search, one that promises to go way beyond just matching keywords and start actually understanding meaning.
But first, I want to start with a question, a feeling I bet we've all had. You have this really specific, complex question in your head. You type it into what's supposed to be the most powerful search engine on the planet, and the results you get back are, well, they just kind of miss the point, right? They feel shallow, disconnected. Why does that still happen?
Well, it turns out it's because the very foundation of the search technology we use every single day has some pretty serious built-in limitations. We've basically been hitting a technological wall for years.
And here's the breakdown of why we keep hitting that wall. First, traditional search is a total black box. It spits out an answer, but you have no idea why it chose that one. It's really just matching patterns of words. It's not actually understanding what you're asking. And this is a huge one. It has zero source awareness. It can't tell the difference between a peer-reviewed scientific journal and some random person's tweet. And on top of all that, it's unbelievably inefficient, just brute forcing its way through gigantic databases every time you hit enter.
Okay, but this is where the story gets really interesting. A new system called HCVN Colbert is built on a totally different philosophy. The goal isn't just to match words anymore. It's about deeply understanding the query itself. At the very heart of this new approach is something called HCVN. That stands for hypercomprehension named vector. You can think of it as the engine that drives this whole thing. It's a hybrid system that cleverly combines two really powerful ideas to create something that doesn't just search, it actually comprehends.
And I think this analogy just nails it. Imagine your current search engine is like a keyword librarian. You ask for something, and it just runs around finding books that have your exact words in the title. That's it. HCVN Colbert, though, that's like having a super intelligent librarian. It listens to your request, understands the intent behind it, knows exactly which aisle and shelf to go to, and even comes back and tells you, hey, this book is a world-class scientific study, and that one over there is just a pamphlet somebody printed.
So all that theory is great, but how does this super librarian actually perform in the real world? Let's put it to the test with a really important query, a researcher looking for COVID-19 treatments.
This is where the magic really happens. Look at this. The entire search is over and done in just 10 milliseconds. Instead of that brute force approach, the system intelligently routes the query to the correct semantic space. Think of it like a specific neighborhood of related ideas. Then it instantly identifies the exact data it needs and scans only a tiny, tiny fraction of it. We're talking just 0.0025%. Then it labels everything and pulls it all together with credibility scores, all literally faster than you can blink. So what makes that semantic fingerprint possible? It's a key piece of the architecture called a named vector. What this means is that every single piece of information isn't just a random bit of data floating around. It has a unique, meaningful label. The system knows the precise context for every single fact, where it came from, and how it relates to everything else.
And this right here, this is the direct solution to that black box problem we were just talking about. The system doesn't just throw an answer at you, it gives you the proof. It shows you its work, tracing every single result back to the specific documents it came from.
Here's what that traceability looks like in practice. It's incredible. So when the system finds info on the treatment remdesivir, it doesn't just see the word, it sees where that word appeared and assigns a credibility score. So a study from the New England Journal of Medicine, that gets a 0.95. An official FDA release gets a 0.90. But a tweet, even if it's from a credible source like the CDC, is correctly identified as a much less reliable source for hard scientific data. That is source awareness in action.
Now, you might be thinking, okay, a system this smart, this detailed, it must be slow, right? Well, this is where things go from impressive to absolutely mind-blowing. The performance isn't just a small improvement, it's a complete and total breakthrough.
Just let that number sink in for a moment. 20,000 times. In performance tests, HCVN Colbert was shown to be up to 20,000 times faster than the traditional systems we use now. This isn't just a step forward, you guys. This is a massive, generational leap.
And here's what that speed actually looks like. A typical search today might take 150 milliseconds, maybe more. This system gets you a much better answer in just 10. That's the difference between waiting for a page to load and getting an answer as fast as you can think of the question. It's basically instantaneous. And it's not just faster, it's also unbelievably efficient. To store information from 1 million documents,
A standard Colbert system needs around 50 gigabytes of storage. HCVN Colbert does the exact same job in just 1.2 gigabytes. That is over 40 times more efficient, which has insane implications for cost, energy use, and just overall scalability.
Okay, so let's put it all together. We have a system that is thousands of times faster, wildly more efficient, and it actually understands the meaning and quality of information. So what? What does that actually let us do in the real world?
The potential here is just staggering. For everyday search engines, you're talking about results that are orders of magnitude faster and come with full transparency. For a huge global company, this could unify all of its knowledge, all its documents, emails, everything across every language into one intelligent system. For scientists, it could automatically scan thousands of papers and assess the quality of the evidence. And in a hospital, it could give a doctor a real-time analysis of a treatment's effectiveness, pulling directly from the latest medical literature. It's a game changer.
When you boil it all down, what we're really seeing here is a fundamental shift in how machines work with information. We're moving away from just matching statistical word patterns to achieving something much closer to genuine semantic comprehension. It's the difference between a machine that can parrot words and one that can actually understand ideas.
And that really leaves us with a pretty profound question to think about. For decades, our search for knowledge has felt like looking for a needle in a haystack. But what happens when our tools can not only find that needle instantly, but also tell us exactly what it's made of, who made it, and where it came from? If search can give us answers with full transparency and proof, what could we discover next?